See the space you have in Appendix 2? Actually, we're going to not worry about that. Let's draw this circuit in number 1. Go to page 1, number 1. Let's draw this circuit diagram. This is a standard circuit diagram that is used with LEDs. Anytime you see an LED, right away there will be a resistor that will be connected in series with the LED to keep what? The current at a safe value of about 20 milliamps. That's what we're saying there. So the current in an LED can be 20, 15, 18, 20. What if you had that resistor so the current went up to 25 milliamps? Will it damage the LED? No. It will be okay. It'll just be a little too bright, okay? But it will decrease its life. These LEDs have a very long life. They can last for years and years and years, okay? But a couple of things to watch out for with LEDs is reverse voltage. V reverse on an LED is about 5 volts, okay? What kind of reverse voltage could a regular diode handle? Lots of voltage, 50 volts, 100 volts, 200 volts, even 1,000 volts, right? For a 4007. With an LED, you give it 5 volts reverse voltage, and it could damage. Current, 20 milliamps. If you push 50 milliamps through it, it could damage it, okay? So those are the things to be careful with LEDs. So, that's that. Now, let's go to the graph at the bottom of page 4. This graph that I was going to talk about for an orange LED. So at the bottom of page 4, I've got a graph. So I find orange, which is number what? 7. So I look for a graph that is for number 7, and I look at 2 items. The items here on the y-axis, which is forward current, I circle 20 milliamps. You follow? Because 20 milliamps is a standard with LEDs, so I circled the number 20. Then I go across and come down, and that happens to be my VF for that type of a diode. So for an orange, if you go across and you look at the, and you come down, what do you get?
2.
About 2 volts. You follow? So that's 2 volts. So that's how you determine the forward voltage given a safe current of 20 milliamps. So we looked at the appendix, we looked at the graph or the chart, the table for the types of material. We looked at the graph at the bottom for the current and voltage. And we looked at the table of voltages for different kinds of LED colors. Okay. Now let's do number 1 on page 1. It says, supposing my supply voltage is 7.5 volts. The LED I choose is a super efficient red. So super efficient red. Make sure you show those arrows pointing away from the diode. So it tells you to go to the appendix to look up the forward voltage, calculate the new value of the series resistor, calculate the value of R if the current is the standard value of 20 milliamps. So, what is the forward voltage for a super efficient red? 2.2. Everybody found the 2.2? Is it in appendix 2? So VF is 2.2 volts. So how much is the voltage at the resistor? Is it 7.5 minus 2.2? How much is that? 5.3 volts. So given the supply voltage is 7.5, 2.2 here, the voltage at the resistor would be 5.3 volts. I know the current that's flowing in this circuit. How much is the current? 20 milliamps. So can I calculate R given the voltage and current? Is it V over I? So is it 5.3 over 20 milliamps? Okay, so you have to take care of the units there because it's milli. You want to convert it to amps to get your answers in ohms. What do you get? How much? 265? So the idea is this. With 7.5 volts and a super efficient red LED, you want a resistor of about 265 ohms, give or take a little bit, okay? Better to go a little bit bigger, like 270 ohms or 300 ohms. That way your current will be 20 milliamps or just below. You don't want that current to be much higher than 20 milliamps. 25 milliamps, okay. 30, 40, 50 milliamps is a no-no.